Alrighty, hello everyone, and hello to people watching on the live stream. Thank you so much for joining us for today's big mini-conf. My name is Diallo, and today I'm going to be giving an introduction to game development in JavaScript. This talk is aimed at people who are JavaScript beginners, so people who have some fundamental coding knowledge under their belt and who are interested in making their own video games, but who have yet to take the plunge. My hope is that today I can show you that the process of creating your own game is maybe not as scary as you have feared. So the agenda for today's talk is, first I'm going to give a brief self-introduction. I'm going to talk about my background with coding and my background with video games. Then I'm going to explain why you should consider making a game in JavaScript of all languages. After that, I'm going to give a brief demonstration of a game that I made. And then finally, I'm going to use that game as an example to explain what the core components of game development are and what you need to do those in JavaScript. So without further ado, once again, my name is Diallo. My handle is @followdiallo. You can find me on GitHub, and also I just made a Twitter, so I'm on Twitter now too. Before joining Code Chrysalis, I worked for 3 years as a Japanese and English translator/interpreter. This next point should come as no surprise since I'm giving a talk about video games, but I'm pretty into video games. Since moving to Tokyo, I've been relatively involved with the indie game scene here, so I go to a lot of game-related events, especially events for game localization. As for my background with coding, I began seriously studying coding this year in March, so still less than a year of experience. But that being said, I've made 2 games in JavaScript to date, so if someone who is as new to coding as I am can make a game in JavaScript, then you definitely can as well. Okay, so why do I think you should make a game in JavaScript? So if you've looked into making your own video games, you've probably seen recommendations for languages like C++, Java, or Python. Or you may have seen people recommend that you use an engine such as Unity. JavaScript, on the other hand, is not particularly well known for being a video game language. So why do I think that JavaScript is a good starting point? Well, for starters, JavaScript is more beginner-friendly than languages like C++. JavaScript is one of the most popular languages out there. In fact, at one point, JavaScript was the most popular language on Stack Overflow. So there are a lot of people out there who are choosing JavaScript as their first programming language. The C++, on the other hand, is notoriously difficult for beginners to learn. So if you're a person who chose JavaScript as your first programming language and you're interested in making games, don't think that this is something that's out of reach for you just because you started with JavaScript. The next point is that there are no special libraries or frameworks required to make a game in JavaScript. Of course, there are plenty out there that you can use if you so choose, but to get a basic game up and running, all you need is pure JavaScript and a little bit of HTML. Next is that if you are a JavaScript beginner and you're still getting a hang for object-oriented programming, making a video game is a really good way to practice that. And I'll explain explain why a bit more later. The next point goes for any programming language, not just JavaScript, but setting measurable goals is a really good way to learn. So if you've done some introductory coding and then you're looking to increase your skills, one of the biggest pieces of advice you'll hear is that you should practice making your own projects. And I think that a video game is a really good first project to work on and something really concrete that you can work towards. And then last but not least, you can create some really cool games in JavaScript. So let me show you some examples. All right, has anyone here heard of a little game called Angry Birds? Yeah, super famous game. Fun fact, this is actually written in JavaScript. And the next game was not originally made in JavaScript, but I went to a presentation earlier this month where the presenter explained how he was able to recreate Super Mario Brothers using JavaScript. So this goes to show you that you can still create some really cool games in JavaScript. Alright, so now that you've decided to make a game, the next step is to create a sort of game plan, no pun intended. So the first question you need to ask yourself is, what kind of game do I want to make? And this might seem like a fairly obvious question, but the reason that you need to ask it is because depending on the type of game you want to make, your process for creating the game is going to be very different. So creating an action game is going to be very different than creating a puzzle game, which is going to be very different than making a racing game. So you need to decide what kind of game you want to make first, and then you'll be able to work in that direction. And then after you've decided the direction you want to go, my next piece of advice for you is to start small and then expand upon that. So you might have an idea for several characters you want to create, or several power-ups you want to include, or several levels that you want to have in your game. But if you try to implement everything at once, it's going to be very overwhelming. So I would say identify what the core areas are that you need to have your game up and running, then start from there, and then once you have that down, you can add to it. So when I was thinking of what I wanted to do for my first game, I knew I wanted it to be some sort of 2D arcade-style game. And in terms of inspiration, I decided I wanted to try to recreate a game from my childhood. So did anyone here play Neopets back in the day? Did anyone remember this game, Jelly Blobs of Doom? Well, I decided I wanted to try to recreate a simplified version of this game, Jelly Blobs of Doom. So let me show you what I did. Alright. Okay, so this is my game. I'm controlling this little white square. I have to avoid the squares that are larger than me. If I collide with one of those squares, it's going to be a game over. But I can also run into the squares that are smaller than me, and if I do that, then I will get some points added to my score in the top right corner. And you might have noticed that my square expanded a little bit. So the more of the smaller squares I eat, the larger my square is going to be, and then the larger squares I can eat. I'm just moving really fast, so let me try to catch this guy. Alright, you can see my square got a little bit bigger. And then if I hit the square, it's game over. Another thing to note is that the squares are being randomly generated with a random starting position, a random direction, and a random speed and color. And I'm using the arrow keys to control my character right now. So that's the basic idea of my game. So now let's break that down and identify what exactly are the core components of that game. So for starters, we'll need some sort of 2D game space, some area to render our game. We'll also need to have some sort of player character. So in that game, that would be the white square that I was controlling. We'll need to have some sort of obstacles, so the pink and purple blocks that were flying around the screen. Then we'll need to have some behavior where if my player character interacts with a smaller block, then he can eat that block. And then the opposite, where if my player hits a block that's larger than him, then he disappears and we get a game over. So without further ado, let's look at what the code for that will look like. So the first element that we're going to talk about is the canvas. As the name suggests, this is literally the canvas for our game. So everything that's happening in our game will be represented on this canvas. In terms of code, what the canvas is, it's an HTML5 element, and we're going to give it 3 properties: ID, width, and height. The width and the height are fairly self-explanatory. They're how wide and how tall we want our object to be. One thing to note is that you might see, we have it defined inline right here, and you might think, okay, I'm not going to define it inline, I'll define it in CSS instead. Well, the HTML height and width properties are slightly different than the CSS height and width properties. So it's best to define it inline, otherwise things will not line up exactly how you expect them to. And then the ID is just sort of a nickname we can give to our canvas so that we're able to refer to it later in our JavaScript file. And then one other thing I would recommend for you is that you give your canvas some sort of border or background color for visibility so that you can make sure that it's appearing as you expect it to. Okay, so now that we've created our canvas in the HTML file, when we want to refer to it in JavaScript, we will do it like so. So we'll first create an element called the variable called canvas, and we'll set that equal to document.getElementById, and then whatever ID we gave our canvas. So in my case, I called it canvas, so I'm doing document.getElementById canvas. And then the next thing we have to do is define that we're working with a 2D game space, and for that we'll need something called context. So we'll create a variable called context, or CTX for short, and we'll set that equal to canvas.getContext and 2D. Alright, now that we have our canvas, there's a lot of different ways that we can make things appear on the canvas, that we can draw on this canvas. So we can draw basic shapes like squares or circles, triangles, lines. We can also have some text appear on our canvas, and we can even include images either from our computer or from the internet. These are some examples of some of the methods that we can use to start drawing on our canvas. So let's take a look at one of them in action. So in my game, everything is a square. The player character is a square and all of the obstacles are squares. So let's talk about how we can draw a square on the canvas. So to draw a square, we're going to use a function called fillRect, just short for fill rectangle, which takes 4 arguments: position x, which is the position on the x-axis, position y, which is on the y-axis, and then width and height. So the top left corner of our canvas has coordinates 0, 0, so x is equal to 0 and y is equal to 0. And the farther to the right we go, the higher the x value increases, and the farther down the canvas we go, the more the y value increases. So by defining the position x and the position y, we can say exactly where on our canvas we'll want our square to appear. And then again, the width and the height are the width and the height of the square. So, for example, if I wanted to make a square, and I wanted it to appear 50 pixels to the right and 150 pixels down, and I want it to be 200 by 200 pixels wide, then I would call fill rectangle with the arguments like so. One other thing to note is that the default fill style for this function is black, but if you want your square to have a different color or maybe a pattern or a gradient, you can define that using another function called fill style, which takes a color as an argument. So if, for instance, I want to create a red square, then before I call this fill rect function, I will call fill style and pass it red as an argument. And then as a result, what we have is this. We have our canvas and we have our 200 by 200 square exactly where we want it to be. So yeah, we've done our very first thing on the canvas. All right, now let's say that I want to update its position. So instead of having it to be 50 pixels to the right and 150 down, I want it to be 150 to the right and also 150 down. So you would think that I should be able to just call this function again and give it the new coordinates. But when I do that, let's look at what happens. Okay, so instead of seeing a square like we expect to, we're seeing a sort of elongated rectangle right now. And the reason for this is because, so this is what we were expecting to see. But the reason that we're still seeing this is that we're seeing an elongated rectangle like this is because when you draw things on the canvas, they remain there. So we drew our original square, and so that's still there, and the new square has been drawn on top of that. So we have a little bit of a problem. Fortunately, there's a function we can use called clear rectangle, which will let us clear the canvas. So this takes the same arguments that the fill rectangle function does. So every time we want to update the position of the rectangle, we'll have to first draw it and then clear the canvas, then draw it again, and then clear the canvas again. And this is going to give us the illusion of movement. And so this is a very repetitive cycle, which brings me to the next thing that I want to talk about, which is something that's very fundamental to video game programming, which is called the game loop. So as your game is running, you're executing certain actions over and over and over again. Lots of updates and lots of redrawings. So in this case, the main components of our game loop are going to be a step that clears the canvas, then a step that updates all of the information of everything that's on the canvas, and then finally redrawing everything according to its new information. And again, we're going to be repeating this over and over and over and over again. What allows us to make this process repetitive is a built-in function in JavaScript called requestAnimationFrame. And this function is essentially asking the browser, please reanimate me again as soon as possible. So we'll create a game loop function that will have these three steps, the clearing step, the updating step, and the redrawing step. And then at the very end of that game loop function, we're going to call requestAnimationFrame, and we're going to pass it the entire game loop function as an argument. So we have some recursion going on in there. Okay, so now that we've set our canvas and we have our game loop up and running, let's talk about actually putting some things in our game. I mentioned at the beginning of this talk that if you want more practice with object-oriented programming, video games are a good way to do that. And the reason why is because basically everything in your game is going to be its own class. So to give some examples, in the game that I showed you, the player is its own class called player. So the little white square is its own class. And then all of the obstacles were their own class. And then often it's helpful if you make your entire game into a class and then have your player and obstacle classes live inside of that class. And then when you have your classes, you can give them some properties that are going to define their characteristics, be that size or color. And then you're also going to give them some methods that will define their behaviors. So let's take a concrete look at a specific example. Let's start off by making a player class. So what are some basic properties that we might want our player class to have? So the little white square in the game that I showed you. Well, for starters, we'll probably want to give it some sort of size. So we'll give it properties width and height. And then we also probably want to give it a position, so somewhere to appear on the canvas. So that could be represented as a set of x and y coordinates, like so. So these are some bare bones properties, and let's see what that would look like in our game world. Okay, so right here we have a 40 by 40 square, which is what we want it to be in terms of size, and it's right now at 0, 0, which is where we told it to be. And you can see on the bottom right of the canvas, I'm representing the x and the y values of the player's position property. So let's say that we want to make this more dynamic now, and we want to have our player character move around. What do we need to do to the player character in order to get it to move? So let's say I want to move it to the right. You can see the farther to the right I go, the more the x value is increasing. So basically what this means is that if I want to move the player character to somewhere more towards the right, I just need to go and increase its position.x value. And then also if I want to move it more towards the bottom, then again the y value is increasing, so that means that I need to increase the position.y value. And of course the reverse is true for moving it up and for moving it left. Okay, so let's talk about what that looks like in coding terms. So if we can actually encapsulate that behavior that I just talked about in functions. So I can create, if I want to move the player right, I can create a sort of move right function, which every time it's called, it's going to update the player's position.x value. Or if I want to move it up, for example, I could create a move up function that every time it's called, it's going to update the position.y value and make it and decrease it. So of course, this wouldn't be a game unless we had some way for a human to actually interact with it. So we need to find some way that we can translate the player's behavior, the player's input into actual behavior for the character. And there are many different ways that we can control the character. For example, we could operate the game by pressing buttons on the keyboard. We could click something on the mouse, or we could just move the mouse around. Or we could use more unconventional input methods. For example, we could have a voice-controlled game. But whatever method we decide to use, we're going to need to have some sort of input handler for that. And for that, we'll need some event listeners. So basically, we need to tell our program to listen out for the actions that we want the player to do. And every time the player does that action, it'll fire off whatever behavior we want it to fire off. So to give an example, like I mentioned, in my game, you control the player by using the arrow keys. So every time I press an arrow key, I'm triggering the appropriate movement function that I want to call. So if I press the up arrow key, I'm calling the move up function. If I press the right arrow key, I'm calling the move right function, etc., etc. And so now we've laid a basic framework for our game, but we have a player class that has some properties and it's got some methods, and so now we can continue to expand to that. So we started off by giving our player class size properties and position properties, but we could also give it some properties like maybe color, or we could give it a speed. And then we talked about some movement methods like moving left and moving right, but of course you can do more than just move in a game. We could also add something like a jump method to allow our player to jump, or if I'm making sort of an asteroid game, I could create a shoot laser method. Basically any sort of behavior you want to be possible, you can create as a method. And then finally, right now, we just have a player class, but of course, the game's going to be kind of lonely if we just have a single player existing in this game space, so we could create some block classes, any other class we want to add to the game. And then one important thing to note here is that we control our player character by using event handlers, event listeners, and input handlers, but to update the non-player characters, we'll use their update functions. So we'll define some behavior that we want to happen every time our game's updating, and we'll put that in the update function for our non-player characters. And the very last thing that I want to talk about today is adding interaction between the different game elements that we created. And for this, we'll need something called collision detection. So the question we have to ask ourselves here is, what happens when two elements in our game collide? So I'll give you some examples of what it looks like in some other games. So when Mario and a one-up mushroom collide, so when they're both occupying the same space, what happens? Well, the one-up mushroom disappears and then Mario gains another life. Or in Pac-Man, if Pac-Man collides with the power pellet, then all of the ghosts turn blue, and then Pac-Man is able to eat the ghosts when he runs into them. And then with this breakout game, we can also see a couple other examples of collision detection. When the ball collides with the paddle, it bounces off of the paddle, and when the ball collides with the brick, a brick disappears, and if the ball collides at the very bottom of the game screen, then the player loses a life or gets a game over or something. So basically, by defining the rules of our collision detection, we're going to define what exactly is happening in our game. So collision detection works by taking two objects and comparing basically, okay, I'm going to look at the top edge of object A. Is this anywhere within the border of object B? No? Okay. Well, what about the right side of object A? We're going to check every single side of object A against every single side of object B. And then we'll do this the reverse. So we'll check object B and see if any of B is inside of object A. And if we find that they are overlapping, so in this example over here, we can see the bottom of object A is overlapping with object B, so that means that there is a collision. So we'll create some sort of collision detection function that says, okay, if it'll first calculate, are these two objects overlapping? And then, in the case that they are overlapping, it's going to trigger whatever behavior we want it to trigger. Alright, so to give a brief recap of everything that we've covered today. So to begin, we have our canvas, which is the area where our game is being rendered, and there's lots of different methods we could use to draw on the canvas. We have our game loop, which is a cycle of clearing our canvas, updating everything on the canvas, and then redrawing everything on the canvas. We're making everything into our game its own class, so we'll have player classes and non-player classes, and then we'll give those properties and methods that define what's going on with them. And then we'll use collision detection to define what happens when things are interacting in our game, and sort of define our game's behavior. And the last thing that I want to mention is that I've shown an example of how to create one type of game in JavaScript, but of course there are many kinds of games out there, and there are many different ways you can go about doing it. So the possibilities are endless. I encourage you to explore and play around with things and see what you find out. If you're curious about the game that I showed you today, it's up on GitHub. Follow Diallo, and it's called the Square game. So you can scan this QR code if you want to check it out. I also have another game. Oh, I'll let you finish doing that, and then. Alrighty, I also have another game that I didn't get to show today, called Infinite Hummer. This is a voice-based infinite runner game. So you actually operate this little green piece by humming like a rising tone or humming a falling tone. It's a little bit similar to Flappy Bird, but voice version. This one's also available on GitHub, so feel free to scan this QR code. And if you play it, please let me know what your high score is. I think right now Vic is the reigning champion with something like 12,000, so see if you can beat him. But yeah, thank you again for coming here today. Once again, my name is Diallo Spears. I'm on GitHub at Follow Diallo, and I'm on LinkedIn at Diallo.Spears. So thank you so much.